All right, so we're going to do surface areas, and that's pretty much what the rest of chapter 12 is going to be about. The important thing is for you to understand what a surface area is. So surface area literally means what it says, the area on the surface. So the best example that I always give is thinking about like a Kleenex box. And a Kleenex box, if we wanted to find the surface area of a Kleenex box, it would be the amount of cardboard that the box is made out of. So like the area of the top, the area of the bottom, the area of the sides, and the area of the front and the back. So the easiest way to explain this, without getting into all of this explanation of all these formulas down here, is it is just finding the area of each side and adding them up. So what you see here is we have a base and we have a base. And if we were to unwind this figure, we would have these two would be the bases, and then we would have all of these would be rectangles. We call these two the bases, and then we call these the lateral faces. Now, when you're finding the area of a prism, a prism always has two bases, and then it will have the number of lateral faces based on the sides of the bases. So when you're finding it, it is true that it will always be the two bases, so the area of this base plus the area of this base, and then it'll be the area of all of your lateral faces. Well, you can use this formula if you want to, and I'll let you read through that on your own, but essentially it's just finding the area of a lateral face and then of each lateral face and then just adding it up. If all of the lateral faces are the same, then you can just multiply it by the number of lateral faces. So let's just get right into the example here of what we're talking about, and then, like I said, we can go through this more in class if you need to. So what we're looking at here is our first problem is we are getting the surface area of a hexagonal prism. So the hexagonal prism here, the one thing you got to notice about this picture is it's kind of unclear. This dot is the center of this bottom hexagon. So that's the apothem right there of that. So if you recall, here we need to find the area of the hexagon on the bottom and the hexagon on the top. And if you recall, to find the area of a regular polygon, it's 1/2 times little a times the perimeter of that. Well, we can easily figure that out as 1/2 times a, which is 11.1. And then the perimeter is going to be, here's one of our sides right here. So we have 1, 2, 3, 4, 5, 6 sides. So the perimeter is going to be 12.8 times 6. So we're just going to plug that right in, 12.8 times 6. So the area of one of the bases or one of the hexagons is going to be 1/2 times 11.1 times 12.8 times 6. And again, this right here, let me label this, the 12.8 times 6, that's the perimeter. The 11.1 is the apothem, and then 1/2 is part of the formula. Now, keep in mind, we have two of those. So now it's going to be 2 times 1/2. Actually, you know what? I'll just give you the answer here. So it's 2 times all of this, which is equal to 852.48. And again, the reason why it's 2 times all of that is because there's two of them, a top and a bottom. So that's 852.48. Now, the other portion is we have the top and the bottom, but now we need these rectangles. And we find the area of a rectangle by finding the base of it and the height of it. Well, the base is going to be the same all the way around. It's 12.8. The height is labeled right here as being 11. So the area is going to be 12.8 times 11. Well, how many of these do we have? They're all the same. Because they're all the same, we can just simply take 1, 2, 3, 4, 5, 6, and all of this will be lateral area will be 12.8 times 11 times 6 of them. So the base and the height will give you the area of one. 6 of them will give you the area of all of them. And that is equal to 844.8 feet squared. And this one's feet squared as well. So here's what you're going to do. To get the total area, we just add these two. So add those two up and we get a total of 1,697 0.28 or 0.28 feet squared. Again, don't make this more complicated than it has to be. Find the area of each individual face. If that's what you have to do, then that makes it easier. So don't go through and get confused and think that you always have to multiply by 6. Just think about what the area of each face is and then add them all up. The two bases will be together, and then the lateral area all the way around will typically be together. Okay? All right, so let's look at this example over here. And let's go through this together because, again, I'm not going to have you guys do this on your own because I think it's worthy of your time to understand this fully. So it's a solve for the surface area of the oblique triangular prism. So we're going to look at some of the information we have here. I'm going to erase some of this right here so we can see. So what it's giving us is we have a triangular prism, which means our two bases are triangles. So what we have here is they're giving us all the information we need. You see this 8 inches. That right there is the height of our triangle. Do we have the base of our triangle? Well, we want to look more in other places on our figure, and yes, we do. They give it to us right here. So that's 10, okay? So what's going to happen here is we know that the base of the triangle is 10. We know the height of the triangle is 8. So to find the area of the base, we will do 1/2 times 10 times 8. Okay? Now, because we have two bases, it's going to be 2 times 1/2 times 10 times 8. That will give us both triangles. Okay? So that portion is equal to 80 inches squared. So that's the two bases. Now we have to think about our rectangles around the outside. So you can see this rectangle right here, we can find the area of that. And again, there are quicker ways to do this using the formula, but I'm going through the way that I think is easiest for you guys. So finding the area of these rectangles, this right here, even though the picture may not seem like it's very clear, it's telling us that the distance between the bases, from the top base to the bottom base, the height of our object is 17. Well, that means that every one of our lines here is going to be 17. So right here, we have an equilateral triangle. So each of these sides are 10. So that means every one of our rectangles is going to be 10 by 17, 10 by 17, 10 by 17. So the area of our lateral faces, or our lateral area, will be 3, because there's 3 of them. And then we find our area of each rectangle, which is 10 times 17. So again, the 3 is because there's 3 of them, and then the rectangles are 10 by 17. Understand, it won't always work like this. Sometimes you will have to find the individual areas of each rectangle, but in this case, because they're all the same, we just multiply by 3. So the lateral area there is 510 inches squared, and now we just add those two up, and we get a total of 590 inches squared. Okay, so that's how we're dealing with the prisms. So let's go back now and let's talk about the cylinders. Cylinders are exactly the same way, except cylinders work out a little bit easier because it's only one formula over and over again. So the surface area of a cylinder is going to be this formula right here. Now, there are other ways to think about it. So we still have two bases. So we have to find the area of those. So that's going to be pi r squared, and that's going to be pi r squared. Okay? Now the other one is going to be, even though it looks like a rectangle as a net, the way that we're going to look at this is think about how a cylinder looks. It's like a tube. So the outside of it is going to be the circumference times the height. So this right here is the circumference of that circle. If you were to unwind the tube, this would all be circular right here. So that right there is the 2 pi r, and this right here is the height. Okay, so what we want to think about is, if you think about a cylinder, it's the top portion is pi r squared, the bottom portion is pi r squared, and then the amount on the outside will be the circumference, the amount around, times how tall that actual cylinder is. That's where this formula comes from. 2 times pi r squared, because there's a bottom and a top, and then 2 times pi times r times h will give us the amount around the outside of that cylinder. Okay, again, let's just get right into these examples. This is easy as long as you have the formula in front of you. So it says solve for the surface area of the right cylinder represented by the net. Round your answer to the nearest hundredth. Okay, so what we have here is we have a radius here. So here's what we're going to do. Here's our formula. 2 pi r squared plus 2 pi r h. Let's plug everything in. 2 times pi times 3.8 squared plus 2 times pi times 3.8 times h, which is 7.2. That should be pretty easy. Put that into a calculator, and we get approximately 262.64 centimeters squared. Okay? So what I want you to do is try and do this one on your own. Okay? So, actually, no, let's go through this together. I'm sorry. So we're going to do the same thing here. So we have surface area equals 2 times pi times r squared plus 2 times pi times r times h. In this one, it's giving us what the surface area is, and it's giving us the radius, but not the h. So the thing that's missing there is the h. So we're going to plug in everything that we know, so that way we can make sure we can actually solve for this. Okay? So looking at this, this is 363.23 equals 2 times pi times 4.1 squared plus 2 times pi times 4.1 and then h. So h is what we don't know. Okay, so we're going to go through and solve now for our h. Okay, and that's going to require us to have decimals, and that's fine. So let's do a different color. 363.23 equals, and then this as a decimal is 105.62 plus 25.76 h. And now we just solve our our two-step equation. Minus 105.62 from both sides, and we are left with 257.61 equals 25.76 h. Divide both sides by 25.76. And we get h equals 10 feet. So again, you do have to pay attention to what they're asking for. If they're giving you surface area, then you're going to use your formula. This is the same thing as before. Write out the formula, plug in what you know, and then solve. Okay? So hopefully that makes sense. Don't forget to do your Edmodo quiz if that has been assigned, and then bring any other questions you have to class. See you guys later.